So hi guys, here we are again. Today we are going to solve, now that we have finished this first integration, for this Fourier series, we have finished this, we have finished this and this. Now we are going to find, the Fourier series. Okay, we are going to find the Fourier series. Not Fourier series. We are done with Fourier series, this one, okay? Okay, now to do this one Veloso, what can I do? Just follow the same steps you did here and you will end with the right expression there. Okay, nice. But if you are in doubt about this one, how to solve this one, just let us know and we will write down the solution of this one. Okay, but the way we solve this one, it's the same way we solve this one. Okay, just follow the rules. Just find what is L first. Suppose here it is 0 to 3. So C 0, C plus 2L, then just find what is L. L here. Here L, that is the period, will be 3 by 2. Okay, then just substitute everything there. And computerize those integration. Now, we are going to solve for question 3, number A. Okay, find the directional derivative of fxyz equal to xyz at the point P minus 1, 1, 3 in the direction of vector A equal to I minus 2j minus 2k. Okay, what do we have to do here? The most important thing to know, here, it is, let us just take out the datas. It is to find the directional derivative. What is directional derivative? The directional derivative, it is nothing more or less, it is nothing more or less than directional derivative is d of a, div of a of a certain function fxy, in this case fxyz. Directional derivative, it is what? This will be the gradient of this function, the gradient of the function, the gradient of fxyz, time its Unitarian vector of the direction that they gave us, will be the gradient time the Unitarian vectors. What is this unit vector? So A, with this kind of cup, this is Unitarian vector. This is the vector itself by its, divided by its scalar unit, by its scalarity. So here the first thing we have to understand is what is the gradient. Just write down the gradient. So we have to do the product between the gradient of a function and the direction of the vector of the given vector will be our directional derivative. And this is the gradient into a point. We have this gradient and they give the points at which this gradient is moving. So first we have to see what is the gradient of the function that they gave us here. Here they gave f of x y z is equal to what? F of x y z is equal to x y z, product of x y z. And they gave us the point. The point is minus 1, 1, and 3. These are the points. So I have to find the gradient of this function, in this point, during this point. So the gradient, nebula f of x, y, z, in this point, will be, can be written like this one, nebula of f, this is minus 1, 1, and 3. Will be given in this way. So what is this directly? What is this? So this one is equal to nebula of x, y, z at given points. This will be what? This will be the partial derivative of f in according to x, partial derivative of x with respect to x, plus partial derivative of f with respect to y, then plus partial derivative of f with respect to z. So we will give this as we have here, this is a product, okay, nabla or gradient of a function. It is a product between a scalar unit and a vector unit. Whenever we have product between scalar and vector unit, it will be always a vector unit. That's why it will be I, okay, j, sending these are the points that will indicate the direction of the vector. So, and here you get j, k, okay, here you get k, okay, so, okay, k. So this is what we are going to do for these points, okay. So substituting directly, we know nabla or gradient of x minus 1, y 1, and this 3 in these points, okay. It will be, first I will derive fx, okay. I will derive this expression with respect to I. So it will be what? This will be del of x, y, z, okay, del x, and this is in I, plus del, okay, del y, and I will derive the same expression with respect to y. This I will call j vector, plus the same del x, y, z, okay, and I will derive del x, y, z with respect to z, and this will be vector k, the direction k, okay. Just do this, okay. Then after finding this one, what you will get, see, okay, what you will get, see, if I derive this one with respect to x, what I will get only with respect to x, just derive this one, this will be only y z I, okay, plus, if I derive this one with respect to y, it will be only x z j direction. If I do the same, it will be only here with respect to z, it will be only x y with respect to k, okay. Now I will apply the points, okay. What are the points? Y is 1 and z is 3, so 1 times 3, I will put 1 times 3, okay, plus x and z. What is x? X is minus 1. Minus 1 time what is z? 3. This will be for j. Plus x is what? Minus 1. Do the same. Minus 1 time what is y? 1. Put here 1. And this will be k. Okay? So this will be our gradient at this point. Our gradient will be here 3i minus, this plus and minus will be minus 3j, and here it will be minus k, okay, minus k. So this is our gradient at the point that they gave us, 1, minus 1, 1, and 3. Okay, now that we found gradient, because here we will substitute here, see, if you see here, we know now what is gradient. Now we have to find what is unit vector. Okay, what is unit vector there? Then they say that to find unit vector, A, okay, vector A, they say that vector A is what? See here, it is I, okay, I minus 2j plus 2k, okay. This will be I minus 2j plus 2k. This is the vector, okay? Now, we want Unitarian vector. This is A upon scalar vector, or scalar of this vector, the scalarity of this vector. So here, what will be? We know what is A, okay? We know. But what is scalar form of this vector? Here, this scalar form, the scalarity of this vector will be root this square, okay, of this coefficient. Take the coefficient of this direction. Here it is 1 square. Then take this one, the scalarity, just the number, okay, 2 square and plus also 2 square. Then there you will find what is scalarity of this vector. Just computerize this one. This will be 9. 1, 4, and 4. 9. Okay? And then from here, we know that this guy, a scalar, this will be 9. Okay? This will be 9. Now that we know what is the gradient of the function, now that we know what is the vector a, and now that we know what is the module of a, that is scalarity of this a, that is 3, sorry, here it is 3, okay, because root 9 is 3. Now that we know, we have just to substitute there, substitute in this formula, in this one, just directly, okay. So what we will have here, we will have directional derivative at this point of fx, okay, at this point from minus 1, 1, and 3 will be what? This is the directional derivative. Will be, put here the gradient first. What is the gradient? We know here, 3i minus 3j minus k. This will be 3i minus 3j minus k. Okay, time, okay, time is we multiplying by what? By Unitarian vector. What is Unitarian vector? This is the vector a upon module of a. Let me see, what is vector a? We say that vector a, it is I minus 2j plus 2k. Here it is 1, okay? Usually we do not write 1 here. I just wrote because I wanted to find the scalar unit of this guy, of this a, okay? So it will be I, okay, minus 2j, then plus 2k. This all is divided by 3, okay? Yeah, this all is divided by 3, okay? Because we want to find this one. So as module of a is 3 and vector is I minus 2j plus 2k, so we just substituted this in here, okay? So again, directional derivative, it is the gradient at that point, the gradient of a function at that point, at a point that they given us, it is this point, at this point, time, okay, time, the vector upon the scalarity of the vector, okay, just like this. Okay, now we have to multiply. We know that whenever we have scalar, whenever we have multiplication between two vectorial, okay, greatness or unit, this and this, two vectorial, multiplication of two vectorial units, it will be a scalar dimensional unit, like this one. I and I, it will be, I multiply this one and this one, it will be 3. 3j negative and 2j negative also, this will be plus 6 only, okay? Because when I multiply two vectors, it will be a scalar, okay? Scalar unit. So minus k and minus 2 and plus 2k, this will be minus 2 without any direction, okay? It's all by 3, okay? Then we will get 3 plus 6 is 9, 9 minus 2, it will be 7 by 3, okay? Then in this way we have found the directional derivative of this function. Okay, thank you.